This presentation covers Section 7.2, Using Arrays. The topics covered in this presentation include bounds checking, alternative array declaration syntax, the initialization lists, and arrays as parameters. Once an array is created, it has a fixed number of elements, called its size. This is also referred to as capital N. This lets the compiler allocate enough space to hold the array as contiguous unit in memory. An index used in an array reference must be an integer, and it must specify a valid element. Therefore, the index value of an element is always in the range 0 to n-1. If we don't follow this rule, the Java interpreter throws an array index out of bounds exception. Java ensures the boundaries of the array are not crossed. An index less than 0 or greater than or equal to n is not allowed, as there are no elements with those indices. What happens if we break the bounds checking rule? Let's examine two common mistakes that would break the boundary checking rules. Given an int array named codes that has a size of 100, we know that the elements are indexed from 0 to 99. If the value of count gets set to 100, and our program attempts to print out codes subcount, Java will throw an out-of-bounds exception. This will be written in red on the output screen, with a reference to the offending line number in the program file. Another common mistake is to code a loop index that goes past the n-1 array element. In this for loop, we used less than or equal to instead of less than size of the array. As a rule, the standard style is to use a less than 100, not a less than or equal to 99, although that would also work. Remember that array is a class, and when we create an array, we build an array object. One of the useful properties that Java provides is the public constant array member length, which stores the size of the array. We can use it in code by using the object name, the dot operator, and the identifier length. Note that length holds the number of elements, the array size, or n, not the largest index. Let's recode the for loop from the previous slide to take advantage of this useful array member. This is the best practice style of coding your for loops that use arrays. Now it will always iterate through the array correctly. Here's some sample Java code from your textbook. It uses the length member. I do want to mention that often the program code we see in the textbook is designed to just illustrate a concept. So in this example, we just have the sample code in main. This is not the style we use when we are writing actual programming solutions. The program will read a list of numbers from the user, stores them in an array, and then prints them in the opposite order. Okay, let's look at the code line by line. First, we create a scanner object named scan. Then we see the array declaration that uses new to allocate enough space to hold 10 double elements. So our array size, or capital N, value is 10 for the numbers array. Recall that Java automatically initializes numbers to 0, so each one of the array elements will hold value 0 to start. The next line prints out the size of the array using the length member. The for loop iterates through each element from 0 to length-1. Inside the for loop, we prompt the user to type in the values for the numbers array. Notice the style here, as it is nicely coded. He uses a print for the prompt that says enter number 1, enter number 2, all the way up to enter number 10. This is done by adding 1 to the index, which we use for the array elements. Remember, our array elements are numbered 0 through 9. But when we prompt the user, we need to be user-friendly and ask for the numbers 1 through 10. Although we nerds are used to counting from 0, the rest of the world doesn't think that way. Note that we just use the index with the array name numbers when we store the input into the array. After storing the numbers into the numbers array, we then print them back out in reverse order. This is a good illustration of how to use a for loop to count down instead of up. One thing I want to note here is that we have not changed the stored order of these numbers. They are still in the order that we added them into the numbers array. This code just prints them out in reverse order. Looking closely at the for loop, we see that to start, we set the index to length -1, which is 9, and that our stopping condition is when index becomes less than 0. This is because we want to print out numbers sub-0, so we use less than or equal to 0 for our condition check. The iterator part counts down instead of our usual up by decrementing the index each time we complete the loop body. So index will be set to -1 after we print numbers sub-0, and this will cause the loop to stop. Please refer to your textbook to see sample output. For the 3rd edition, it is on page 346. Alternate array syntax. There are actually 2 different ways to declare an array. We can put the brackets after the type or after the identifier name. The preferred style is to put the brackets after the type. It makes it very clear as we start to read the declaration that we are talking about a collection of floats. The second style doesn't tell us that until the end of the declaration. Philosophically, this is similar to the Spanish language practice of putting the upside-down question mark in front of a question sentence. We know right up front that the sentence will be a question, which is a really nifty feature of the Spanish language that English doesn't have. Using that same strategy, good coding style dictates that we use the first style listed, and we will continue to do so for the rest of the semester. Initializer lists. Java provides us with a shortcut way to declare and initialize arrays using a construct called an initializer list. We have already seen this used. Do you recognize the style of using values inside braces? Yes, that's right. It is like an enumerated type declaration. But we also must include an assignment operator because we are actually storing these values into the array's memory cells. The left side of the declaration is the same as we have seen before, but the right side is different. We don't use the reserved word new with primitive type arrays, and we don't have to declare the size. Java counts the values and automatically fixes the size of the array to match the number of items in the list. They will, of course, still be indexed from 0 to n-1. So integer array units will be size 10, as there are 10 initial values listed. Char array letter grades will store a length of 5, as there are 5 chars in the initializer list. The use of the initializer list is only allowed when we declare the array. We can't use it later to do array assignment. This sample program demonstrates the use of the primitive integer array named prime nums that uses an initializer list to set its starting values to the first 8 prime numbers, 2, 3, 5, 7, 11, 13, 17, and 19. Therefore, the length of prime nums will be 8. Note the use of the for each iterator loop to print every element of the prime nums array. The for each loop is convenient when you will process all of the elements of the array. If you only wanted the first 5 to print out, you would need to use the regular for loop and adjust the terminating condition to be less than 5. The last topic of this presentation is about using arrays as parameters in programs. We can share arrays between different methods in our program by passing them as input parameters. In the first bullet, we see a call to method countLetters that passes an array named array. Below it is a method header that shows the syntax for accepting an int array parameter to the method countLetters. Like any other object, the reference to the array is passed, making the formal and actual parameters aliases of each other. Therefore, changing an array element within the method changes the original. The important thing to remember is that there is just one copy of the array, and when countLetters changes an element in my array, it will also be changing the original array that was passed as the argument. It is also important to remember and understand that each array element is still an individual variable that can stand on its own, so to speak. We can always use an individual element anywhere we could use any other variable of that particular type. Therefore, it is perfectly acceptable to pass just one element of an array as a parameter by using its array name and index. Note the sample call to method countAs and using just the first element of the array, array sub 0, as the argument. This lines up with the countAs singular int parameter that is named acount inside countAs method. I will create one more short video that demonstrates using arrays as parameters by altering listing 7.2, the letter count program. The final video for Chapter 7 this week will walk you through that code, but with modifications to demonstrate passing arrays as parameters to methods. Next week, we will move on to the powerful combination of arrays and objects. The ability to store a collection of objects in an array is a very useful and common programming data structure. Happy coding!